Hello everyone. So in this video we are going to discuss the solution of this question. This question is from Combinatorics again, and it's a basic counting. So you can see that in this kind of questions you have already encountered, but it's a little bit twisted, in which the two rectangles are stacked in a different way. Suppose I will give you the simple plain version of it. If I stack them side by side, you can see that there are four right movements in this first grid and four right movements in the second. In total, if I stack them side by side, I have 8 total right movement and 8 total up movements, and we can say there are 16 total movements, out of which 8 are identical all the right and 8 are identical up. So in that way your answer should be 16 factorial 8 factorial 8 factorial. So that should be 16C8. So this is the way in which the plain question is given to you. But the only thing in this question is a twist, is these 3 points are here disturbing elements. So how do we tackle this situation? We have to understand. So I will give you 2 methods. The first method is basic counting. I have counted really how do we actually approach from basic, just to show you. And the second is the smarter way. So let's see. So the first is this one. So the basic counting works like this. Suppose you have to start from A and you are going till the final position F. The idea is that from A we are moving each corner point, because we are moving from left to right and from bottom to top. So each right top corner of the each grid is the subsidiary destination, and we are counting the number of ways to reach destination in every step. So what is the idea? Suppose you are starting from A. From this line, wherever you go, wherever means wherever point are there, at any point you want to go, there is only one number of ways. Number of ways to reach there is only one. In the same way on this side, the number of ways is 1. So what I've written there, the letters, is the indication at the number of ways to reach this point in all the possible ways. So from A, if I'm reaching here in one way and reaching here in one way, so of course to reach this position is 2 ways. And after that everything is smooth. If you just found 1 or 2, everything will be easy to handle. This is the number of ways to reach this point, and you can see to reach the position there I will have 3. Why so? Because one way we can go from there, one way we can go from here, and one way we can go from here. But you can also notice what is happening, that this is the number of ways up to here, and we are adding this one to this 2 to get this 3, and it will be followed for every other grid if you are moving forward. You can see, to find the number of ways to reach this position, you can add this position number of ways and this position number of ways. So that will give you 3 plus 1, 4. In the same way, if you have to find this position, what we get? 4 plus 1, 5. And so if you just make this thing continuous, so here this is what? 2 and 1, 3, and then 3 and 3, 6, 6 and 4, 10, 10 plus 5, 15, and 1 plus 3 plus 4, 4 plus 6, 10, and so on. So this is the idea we have to actually apply for each. So up to here we got 15, but after getting 15 there is no such position here so that they can be added. So therefore the number of ways to reach on this line at every point, this will be remain 15 only, because once you reach here and there is no such number of ways supporting it, so it will give you 15, 15, 15, 15 for each position on this line. In the same way, when we approach this 35 and 35, we got this 70, and on the left of this there is nothing there, so the number of ways to reach this position and this position will become 70. And after that again we have to follow this thing, so 120, 70, and so on, and we have to just count this thing, and this is the simple counting, and you get this two ends as 1275 and 1000. You get the sum as 2275 as the final answer. But Of course, if I have this much patience, we can count it and we get the answer, but it's satisfactory also because you are not using any such kind of mental work. You are simply counting this thing, and from your simple class third and fourth counting skill, you can count this number of ways to reach the final destination from me. But how do we approach in a more sophisticated adult way? So what is that? This thing 6c4 into 8c4, what I have written, please understand. The idea is that here, that is, I am actually positioning these 3 points, or not positioning means I am just assigning these points name. So what is the name? Let's say this name is B here, this name is C here, and this name is D here. So these 3 points, because these are the disturbing points. Excuse me. So first of all, I want to reach B. So to reach B, the number of ways is 6c4, because this is the rectangle I have to consider to reach B from A. It means you are actually moving 4 units on the right and 2 units on the up. So total 6c4, because 6 factorial divided by 4 factorial into 2 factorial. So this will give you the number of ways to reach A. After reaching A, you can now consider a new system. From there, you want to reach towards F. So this is the total number of grids you can find. So there are 4 right movement and 4 up movements, so total 8 movements, in which 4 and 4s are identical. So therefore 8 factorial divided by 4 factorial into 4 factorial. So this will be 8 choose 4. So this is the, you can just collectively say this is the number of ways to reach from A to F via B. Yes or no? I'm not writing this, but I'm repeating it. This total is number of ways to reach the final destination from A via B. Okay. Now we try to reach the same destination via C. So to get that, I have to consider this rectangle, isn't it? If I'm considering this rectangle, the total number of ways to reach C is what? This is 4 on the right, 3 in the up. So total 7 factorial divided by 4 factorial, 3 factorial, which is 7c4. But the problem is, in this you have already counted, you have overcounted the number of ways in which you reach C via B, because in process of counting the number of ways to reach the final destination via B, you have also counted this thing. It means you are coming from A, or maybe you have counted this thing there, but you are moving from here to C only. In that you have also counted that. So I have to just remove that. How do we remove? We simply remove the number of ways in which you are actually moving at B from A, because when you move at B, it is automatically counting the number of ways from B to C, how many ways you have moved. It means from there 7c4 is the number of ways, total number of ways to move from A to C. 6c4 is the total number of ways to move from A to B. I don't need it because it is over counting, because it already counted here, and this is actually the number of ways to reach the C via B. I don't need it. So I removed it, and from C position, now I have to reach the final destination. So what I do, I simply understand this grid. I will consider this grid, these grids, and in these grids I have 4 right movement and 3 up movements. So again 4 and 3 7, so 7c4 is multiplied to this. Again I will count the number of ways to move from D to F. Via D, how do we move? So I have to consider this total grid. means this entire grid I have to consider. So the number of ways to reach D from A is what? You can simply guess 8C4, because A for this side, and total 8. So there will be 8C4, but from there I am removing the number of ways in which you moved to D via C. So that is already you have counted here 7C4, and you are subtracting from this 8C4, and after this is the total number of ways you move from A to D but not via C. And so you are now at the position of D, and from there you want to move to F. So I have 1 2 3 4 right and 2 up, so 6C4 will be there, and you are multiplying them. And after that it's not so hard. 6C4 is 15, 8C4 is 70, and so on, and you do the calculation, you get the same answer, 2275. And so this is the way we can solve this question. See you in the next video. Stay math active.